Hi, everybody. Today, what we're going to work through, you can see the title just up at the top of the page. We're going to work through rate of change. And so as we go through to address rate of change, I just want to make sure that we are all very good, that we've really been talking about rate of change for the last day. That when you give a quick read into that box, you'll notice that a rate of change describes how one quantity changes compared to another. And then maybe the most important part is in that middle frame. If we were to go through and we were to graph that relation, then the slope of my graph has the same value as my rate of change, or you see that little ROC, as my rate of change. Keep in mind, we are all very, very good at what slope is. We know that slope, and I swear I could almost hear you saying it out loud, is equal to rise over run. That notice that what that is our change in one quantity. That's how we change vertically, compared to our change in another quantity. How do we move horizontally? That slope is actually a generic term for us, anything mathematically. We tend to think about it when we talk about relations, when we graph abstract things, that really all we're going to do today is we're going to put a specific scenario to it. We're going to talk specifically about a rate of change. So since we are jumping into it then in a particular situation, it's important for us to know that all rates of change require units. Okay, they all require units. So we got to make sure that we put those on. Okay, today should be a pretty straightforward day. It should be a little bit of a sum up day actually as well. So let's jump right in. So you see on your page that we have the following situations, and I've given you 3 pictures to represent those situations. I've also given you down below the scenarios that each one of those pictures could represent. And all I'd like you to do is to follow the instruction. Match each one of those scenarios to its picture. Okay, that's what you're going to do. So, like simply write 1, 2, or 3 with the matching graph. Okay, I want you to do that now. Pause the video now. Okay, and so as we work our way through, I'm just going to get rid of those highlights. We're going to see if we match up a little bit. The first one says that the cost of the banquet is $200 plus $100 for every 2 people. The second one says you pay a flat fee of $200 to rent out laser tag. And 3, you drive 250 kilometers in 5 hours. Okay, well, if I'm going to try to match those scenarios to the graphs, then I have to think about what would be measured on each axis. I think it might have been pretty easy, or the easiest of the 3 at least, I should say, if we were to focus in on the you pay a flat fee of $200 to rent out for laser tag. That I'm hoping that when we see that, we may have matched that up, yikes, with graph C. Okay, why could that be the case? Well, it's talking about an amount of money we have to pay, and so maybe then I label that vertical axis as a cost, if I picture that that's my cost. So hopefully we can see that whatever that dollar amount is, it is the same regardless of what happens on the other axis. Therefore, it is a flat fee. Okay, well, what could be measured on the other axis? I don't know how you thought about it. I really don't. Like maybe you said, okay, like I've gone and played laser tag before, and sometimes what you can do is you can rent it out like an entire room for an unlimited number of people. So maybe my other axis is N. It doesn't matter how many people I have brought in. It's going to cost me a certain amount of money to play. But I could have also had some people who said, like, no, but like maybe it's like fixed. Like I get to rent the place for like a full hour, but that's all I get it for. So maybe my T is time. And so it doesn't matter how much time I have it for, I still pay the same amount. A couple different ways to think about it, but some things to consider. So hopefully that's what we've got for graph C. Okay, that leaves the other two. I think the next easiest one may have been situation 3. And I'm hoping that we match that up with graph A. The reason for it is, well, maybe if we were thinking about what each axis would be, then we might consider maybe D for like distance, the distance that I've traveled, and my horizontal axis being T, my amount of time. That there's one really important feature with that graph. It says you drive 250 kilometers in 5 hours. So I drive like the first hour, which means I drive this distance. Then I drive the second hour, so I drive that distance. And the third hour, that distance. And the fourth hour, and the fifth hour, something along those lines. For me to be able to go through and view it that way, one of the big important things for me is maybe the fact that I'm starting at that point. That is, if no time has passed, then I haven't driven at all. And so the fact that my graph goes through the origin, that it goes through at 0, might have been what tipped away that situation 3 should have matched up with graph A. Okay, process of elimination is going to take me then that situation 1 is going to match up with graph B, but I better make sure that that makes sense. Okay, so the cost of a banquet is $200 plus $100 for every 2 people. So that would mean that I was measuring cost on my one axis, that would be my dependent variable, and N, my number of people, being my independent variable. The number of people who show up are going to determine my total cost. The fact that we started then at like $200 and then increased for every 2 people that show up should allow us to confirm that, okay, yep, situation 1 does match up with graph B. So if I just get rid of my little zigzag there, I'm hoping that we've got something like that sitting on our page. Okay, I want to take those scenarios now, and I want to jump in and deal with something a little different. So you have your graphs listed right above what I have. Now what I want to do is take those exact same 3 situations, and I want to go through and I want to determine the rate of change for each of them. So we are focusing in on the rate of change for each of those graphs. So let's deal with our scenario. So I'm lining up with my scenario. So I'm dealing with number 1, so I'm dealing with number 1. The cost of the banquet is $200 plus $100 for every 2 people. Okay, I'm hoping that either in the situation or by you looking back up at your graph, we can tie together that in that situation, this 200 does not relate to my rate of change. Like quite often, we would actually refer to that 200 as your flat fee. We've even done a scenario where we would call that your fixed amount. That what we have in that scenario then is a $200 amount that we have to pay regardless of how many people show up. So if I just get rid of all that, then maybe we can see why that would happen if we were to have a banquet. If we were to host a banquet, we pay $200 to like book the facility, and then there's extra costs involved for every couple that show up, for every 2 people that show up. So what actually represents the rate of change then? Well, this is the only portion that represents any change. The 200 is fixed. What we're going to have to pay extra for is, well, for every 2 people show up, we have to pay an extra $100. So what is my rate of change? Well, we just denote that as like ROC. That means that I have $100 for every 2 people. And so if we make that calculation, then we get 50. And if we go way back to Unit 1 at the beginning of this year, we'll remember that what we have in that instance is my 100 is measured in dollars and my 2 is measured in people. And so my division line represents the word per in our rate of change. And so therefore, when I put my units on, I really have $50 per person. And there's my rate of change. Okay, now that I've walked through that first situation, I want you to tackle 2 and 3 on your own. Okay, so go through and deal with what would be the rate of change in situation 2, and what would be the rate of change in situation 3. Okay, pause the video now. Okay, we're back. So, in that second scenario, I have you pay a flat fee of $200 to rent out laser tag. Okay, well, my rate of change then, well, what's changing? Well, my cost is not changing at all. Divided by, and well, I don't really know what I'm dividing by. Am I dividing by a number of people? Am I dividing by an amount of time? I'm dividing by something. But 0 divided by that anything is going to give me 0. Now, the important thing is that when we are calculating a rate of change, if it's 0, it won't require units. But we could have put on something like $0 per person. Or maybe we said $0 per hour. However, we're going to end up dealing with that situation. Okay, let's confirm with problem 3. You drive 250 kilometers in 5 hours. Notice there is nothing fixed about that. Everything is changing. So my rate of change is my total distance divided by my amount of time. So if I asked you, well, what was your rate of change in that situation? You would hopefully tell me that it was 50 kilometers per hour. And there we go. Okay, so there's us calculating our rate of change, and there is us ensuring that we can deal with our units. Okay, I'm just going to put a quick picture down for each one of those graphs again. So if I was to just put down a quick set of axes for the first one, you can see above, so you don't need to rewrite this out. In that first scenario, we should have then seen that we had a graph that did something like this. Now we take a look in that second scenario, and our graph did something like this. And in our third scenario, our graph did something like this. I want you to notice a couple quick things. First off, do you notice that this starting point on your one graph is the same as your starting point on the other graph? Why? Because they both represent that starting amount of $200. Now that we knock that out of the way, I want you to take a look at your rate of change. First off, can we look in the middle at the red? Our rate of change was 0. And what do we know about the slope of that horizontal line? It's 0. Our rate of change is our slope. Maybe you can also look now at what you see between the first and the last graph that match up in these scenarios. These are not going to match with the same location of these graphs above. But when we take a look at these, notice that the slopes of those two other graphs are the same. They might not look at like it because they're a little separated, but those are the same steepness. How do we know that they're the same? Because they have the same rate of change. It's 50. Now, they represent two completely different situations. One's a cost per person, the other one's a kilometers per hour. But our slopes are the same. Our rate of change is the same. Okay, hopefully that just gives us a little bit to deal with the rate of change. Now we're going to jump into something that looks totally unrelated. So we're going to bounce around a little bit on the page, and we're going to skip over some stuff. But I just want to make sure that we're good to go back and address something that we actually reviewed way back in Unit 1. So I want you to give that problem a read. Pause the video now. Okay, we're back. So when you give that problem a read, the question says, what is Hawley's rate of change of number of breaths? And so you see in that information that Hawley takes 62 breaths every 5 minutes. So for you to calculate that then, you could take your 62 divided by 5. And now, since we are dealing with a rate of change, we want this to be as exact as it can be. However, we don't normally talk about things in that regard. Like, notice that blue fraction is fully simplified. So if I asked you the red highlighted question, hey, what's Hawley's rate of change, number of breaths? Like, I know one part of my answer. One part of my answer is going to be breaths per minute. I just want you to notice that if you answer that question the way you have your answer, it's not the way that people talk. Like if I asked you, hey, how many breaths are Hawley taking per minute? And you said 62 fifths. Then people are going to look at you weird. Because we don't talk that way. When we address a rate of change, we're permitted to use approximates. So this is not like calculating slope. Yes, slope and rate of change are the same thing, but we have different expectations for when we talk about something as slope versus when we talk about something as a rate of change. So we're going to actually do the calculation of 62 divided by 5, and you're going to tell me 12.4 breaths per minute. Notice, that's more like the way people talk. Like, hey, how fast is Hawley breathing? What's Hawley's breath rate? 12.4 breaths per minute. That becomes something that is a little more measurable and understandable when measurable. Okay, let's jump into the next one. Okay, so this is where I said, we're going to bounce around a little bit. So we're going to jump down to the race car driver. My number will not match up with your number. That's okay. A race car driver completed a 500-kilometer closed course in 2.8 hours. What is the rate of change of distance? Then take a look at question 3. Well, not your 3, but 3. The cost of renting a car is $75 plus $60 for every 3 days. What is the rate of change? So what I would like you to do is I'd like you to answer both of those questions. Okay, pause the video now. Okay, we're back. So when we go through and we need to find our rate of change of distance, then that's asking us to take our total distance and how long did it take to complete that distance. And so if I was to calculate them, my 500 divided by 2.8, I do not know that off the top of my head, then I'm going to get approximately, and so there's my dot above my equal sign, 178.57. Now, there are no inherent rounding rules in this case, so I'm going to round off to 2 decimal places. What units are we talking about? Kilometers per hour. Now, okay, it was a race car driver. Yeah, that makes sense then. That race car driver's going pretty fast. There we go. Okay, let's get a little confirmation on number 3. The cost of renting the car is $75 plus $60 for every 3 days. What is the rate of change? Okay, I'm hoping that no one was distracted by that 75. Notice that 75 is our fixed amount. The cost of renting that car is $75. You got to pay that up front. And then we also have to pay $60 for every 3 days that we have. Now, as we work through that, the rate of change isn't so descriptive to me. It doesn't tell me what rate of change to calculate. However, we can see that information. It's $60 for every 3 days. So we could take that $60 and we can divide it by those 3 days, and hopefully we end up getting $20 per day. And there's our rate of change. Okay, that's it for today. I think if we're able to work through that stuff, we can recognize the differences between calculating slope versus calculating a rate, then I think you guys are good with where we're going. Job now, jump in and get some practice. Okay, good luck.